So I just was checking this video over just to see where I left off and to make you guys the next one in the series here. And luckily I caught it because my voice sounded like Darth Vader and it was virtually impossible to hear. So this is the second way to calculate elasticity. So before you used the total revenue method, but now you're going to use what's called the midpoint method. And you're going to use a formula. And the formula, I'll be honest, is if you're going to look at it, you're going to say, man, that's confusing. That's a lot to remember, Mr. Sutton. It looks daunting. And it does a little bit, but I would remind you of a couple things. First, you don't get to use a calculator on the test. So the math cannot be that difficult if they ask you to do this and use this problem. The second thing is, if they give you the price and quantity, which are required for this to calculate this using the midpoint method, you could just as easily use the total revenue method. And the total revenue method is easier and probably faster than the midpoint method. So knowing how to set this formula up is not necessarily the most important thing, but understanding how it works and what the calculations tell us at the end of the day, those are important things to know. So here's what we're going to do. I'm going to unveil the formula here, and I want you to write it down. And then we're going to go back and look at a problem that you just calculated for me not that long ago, because we know the answer to that problem, and so it's going to help us examine this. So the price elasticity of demand looks like this in layman's terms. So what we've been doing with the total revenue method and talking about elasticity, or the price elasticity of demand, is talking about, well, when the quantity demanded changes, how much or how big is the quantity demanded change compared to the change in price? So here you see it's just written out that way. So the percentage change in quantity demanded over the percentage change in price. Now the midpoint method helps us calculate this, and it looks like this. Now again, it looks kind of daunting, it's hard to remember, but write it down for me and then listen a little bit here. So in the book, they'll talk about a couple different ways to do this. The midpoint method is essentially the most accurate mathematical way. Without getting into a whole lot of mathematical discussions here, it kind of depends how you look at the change in price and quantity. Because if you look at a change, so let's say from 2 to 4, that's a 100% increase. But if you go from 4 to 2, it's a 50% decrease. And so they look kind of different percentage-wise. The midpoint method allows you to average the difference, essentially, and come up with a more accurate average percentage change. If you want more, you can look into the book, but the bottom line is this is the way to do it. All right, it's going to be the most accurate. So let's go look at a problem that you have seen before. Let's go look at this guy. So this is the one that we did a little bit ago here. You notice all of my prices from 2 to 4, 4 to 8, they double, right? And the same is true for my quantities, 4, 8, 16, they double all along. And if you notice, when we went from 2 to 4, our quantity went from 16 to 8. So we doubled our quantity and we doubled our price and cut our quantity in half, and that was the relationship that I set up for you. So we already know what the answer to this problem is. We know that it's unit elastic. We figured out that when the price changed, the total revenue stayed exactly the same. So we know it's unit elastic. The question is, how can we use this midpoint method? We already know the answer, but we want to calculate using the midpoint method so that we can kind of prove that it works in both ways. So what you're going to do here, and I took the liberty of setting this up for you. So down here is your formula for the midpoint method. Honestly, it doesn't matter what's P1, what's P2. It doesn't matter which is your 2's and your 1's. But you do have to make sure that your P1's correspond with your Q1's. So you wouldn't want to do $2 as P1 and 16 as Q. Let me say that again. You wouldn't want to do 2 as P1 and 4 as Q1. That wouldn't be good because that's not the relationship. Okay, that would mess you up. So I've got my 8 and my 4. They correspond with each other. So they're my P2 and my Q2. And likewise for 2 and 16. So I'm going to type this out here. So let's see. The top part of my formula is going to be Q2, which is 4, minus Q1, which is 16. All right, I'm going to divide all of that by Q2, which is 4, plus 16. All right, and I'm going to divide that by 2. Okay, and that's the top part of my formula. Now I'll do the bottom part, and I'm going to set it up the same way. Okay, so now I'm going to take P2, which is 8, minus P1, which is 2. Okay, and if I'm going too slow for you, you can fast forward a little bit, and then I'm going to add them together. And again, it doesn't really matter if you put P2 or P1 first. I think it just helps that if you always think, okay, P2 and Q2, the 2's go first, and you stay consistent with that as you write it out, it might make your life a little bit easier. But 8 plus 2 is always the same as 2 plus 8, so it doesn't make a big difference. So there we go. So I got my formula set up. Now I'm going to solve this here. I'm going to work this through, and so you have to do that too. Okay, so I put my divide here. So I'll work the top here first. So 4 minus 16. 4 minus 16 is going to give me a negative number. So I'm going to go negative 12 here. I'll tell you about that in a second. Negative 12, we're going to divide by 4. So we got 20 divided by 2, which should be 10. So it looks like this is going to work out. The top is going to be negative 12. Oh, that was good too with my mouse. Divided by 10. Okay, and then it's going to go over something. So 8 minus 2 is 6. Divided by 8 plus 2 is 10. Divided by 2, okay. So 10 divided by 2, so I get 6 over 5. Now go ahead and punch that into the calculator. See what you get. 12 divided by 10 and 6 divided by 5. I already actually know what the answer is going to be. So I'll just kind of chill out and wait for you for a second. Now I'm going to guess that you came up with negative 1.2 over 1.2, right? And so that equals a negative 1. Now here's what I want you to do. I want you to erase, where's my eraser? This negative here. It actually means squadouche here. You can get rid of it because we're always going to think of the absolute value when we calculate this. Because no matter how you tabulate this, where you put P2, however you arrange your P2s and your Q2s, they're always going to come out as a negative number because the demand curve is a negatively sloping line here. And so when we compare the price and the quantity, something is always going to come out negative here. So the truth of the matter is, it doesn't really matter how you arrange the numbers as far as Q2 minus Q1, because whether you get a negative or a positive makes no difference at all. You're always going to use the absolute value, because this is how we know that this curve is in fact unit elastic, because I'm going to show you the rules right now. So when you do this whole calculation, where is it? I want you to write this down here on your slideshow sheet here. If the answer comes out to be 1, well, just like we showed, that's unit elastic, right? Less than 1 is going to be inelastic. Greater than 1 will be elastic. And again, if you look down here, this is kind of what I said at the beginning. This gives you the best answer using the midpoint method, as opposed to the other mathematical approaches that are similar to the midpoint method, but not exactly the same. All right. Okay, and so at the beginning of the video, I told you, like, being able to do the calculation and memorizing the specific formula is not necessarily the most important thing, but understanding how the formula sets up and being able to understand how the numbers come out greater than or less than is really, really important here. So what I want you to do is I actually want to go back here. So I give you this acronym here: price elasticity of demand. Please eat delicious quail delicacies over poop. So if you can remember that quantity demanded, QD, is always over the price, this will help you a lot here. Because if I go back and look, I want you just to think. Just think. You don't have to do any calculating here. But think about our behavior when we've talked about our inelastic product, our insulin, right? So when the price of insulin, let's say the price of insulin goes up by 100%, So let's say the percentage change in price is 100% on the bottom. Well, what's true about your quantity demanded up top? What's going to be true? If insulin, remember we're dealing with insulin here, I'll even write it over here. If the price of insulin goes up 100%, the quantity demanded changes like 1%, probably even less than that. But if you have 1 over 100, the answer comes out as, I'll write it right here, 0.01. And that is less than 1. It's inelastic. Okay? So if you can just think about how the formula actually works, then it makes your life a lot easier than feeling like you have to figure out. And sometimes what they do is they just give you, they say, okay, the price changed 100%, the quantity demand changed 1%. And you have to figure out, is it elastic, inelastic, unit elastic, or whatever. And we can switch it. We can think of it in the reverse too. So let's imagine that instead of the price changing 100%, it changed 1%. So this would be like our apples here. So imagine the price of the apples changed 1%. The quantity demanded would change a lot. It would change a big number, 100%. Probably not 100%, but play along. And so then your price elasticity of demand is, instead of 0.01, it's 100. So it's greater than 1. It's elastic. It's a very elastic product. Okay. Now here's what I want you to do to finish. Or let me reiterate that one more time. So you don't necessarily need to think so much about remembering P2 minus P1, blah, 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 about the formula. But thinking about how the formula works is really important and crucial to your success. So what I would like you to do, I would like you to take the next two slides on your slideshow. Look like this guy and this guy, okay? And I want you to go through, I want you to try to read the directions. They ask you to determine if it's elastic, inelastic, using the midpoint method. Again, you should be able to check the answers with your total revenue method. They're the same problem, so they should come out the same way. All right? Go do that now, and we will talk in a second.